Welcome to Geometry, Section 1.5, Exploring Angle Pairs. In this lesson, we're going to talk about different pairs of angles that are formed. Complementary angles, which together equal 90 degrees. Supplementary angles, a pair of angles that together equal 180 degrees. Vertical angles that are formed by two intersecting lines. Their relationship is that they are congruent. And linear pair, this is a special pair of supplementary angles that form a straight line. Our lesson objective is to identify special angle pairs and to use their relationships to find angle measures. Your essential understanding for this lesson is that special angle pairs can help you identify geometric relationships. You can use these angle pairs to find angle measures. And our standard for this lesson is listed below. Two coplanar angles, angles that are on the same plane, with a common side, a common vertex, and no common interior points, are called adjacent angles. In this figure, angle 1 and angle 2 are adjacent angles. They share a common vertex and a common side. So angle 1 and angle 2 are a pair of adjacent angles. Angle 2 and angle 3 are also a pair of adjacent angles. They share a common vertex and a common side. So they are also a pair of adjacent angles. Angle 1 and angle 3, they do not share a common side. They share a common vertex, but they do not share a common side, and therefore angle 1 and angle 3 are non-adjacent angles. They are non-adjacent angles. They are not right next door to each other. Two angles whose sides are opposite rays are called vertical angles. Another way to describe vertical angles would be to say they are two angles that are formed when two lines intersect. Angle 1 and angle 2 are vertical angles. Another thing we're going to learn is that vertical angles are congruent to one another. Angle 1 and angle 2 are a pair of vertical angles. There's actually another pair of vertical angles in this picture. Angle 3 and angle 4, they are vertical angles to each other. Therefore, they are congruent to each other. They are not congruent to angle 1 and angle 2. Angle 1 and angle 2 are a pair of vertical angles. And angle 3 and angle 4 are another pair of congruent vertical angles. This picture is an example of not vertical angles. Angles 1 and angle 2 are not vertical angles, and it's because although they share this one line, this does not form a pair of vertical angles. This is not a straight line, and therefore these are not vertical angles. They have to be formed by two straight lines. So because this piece here is not a straight line with the other side, then they are not vertical angles. Here's another example of vertical angles, a pair of angles that are formed by two intersecting lines and they are not adjacent. So in this picture, angle ABC and angle DBE are vertical angles. These are vertical angles. Therefore, they are congruent to each other. Another pair of vertical angles in this picture are angles CBE and angle DBA. This is another example of vertical angles. The next pair of angles that we're going to discuss are complementary angles. Complementary angles are two angles whose measures have a sum of 90 degrees. They're complements to one another. This first example, this angle that's 35 degrees and this angle that's 55 degrees, they are non-adjacent, but that doesn't mean they can't be complements of one another. The definition of complementary is that when you add them together, you get a sum of 90 degrees. They don't need to be touching to be complementary. This second pair is a pair of adjacent complementary angles. When I add them together, they have a sum of 90 degrees. So this second pair is adjacent. The first pair was non-adjacent. They are both still complementary angles. Next, we have supplementary angles. Two angles whose measures have a sum of 180 degrees are supplements of each other. This first pair, they are non-adjacent, but when I add them together, they have a sum of 180 degrees. This first pair is a non-adjacent pair of supplementary angles. The second pair, they are adjacent because they share a common vertex and a common side, and therefore they are an adjacent pair of supplementary angles. These are actually called a linear pair of supplementary angles because their opposite rays form a straight line. Example 1, let's identify some angle pairs from the picture on the right. What relationship or relationships can be used to describe angles 1 and angle 2? Angle 1 and angle 2 are here. They share a common vertex and a common side, so that makes them adjacent angles. They are also together to equal 90 degrees, so that makes them complementary. Let's talk about angles 3 and 6. What relationship do they have? Angle 3 and angle 6. They are formed by two intersecting lines. Therefore, they are vertical angles. If angle 3 is 90 degrees, we know that angle 6 would be 90 degrees because vertical angles are congruent. 90 plus 90 is equal to 180. So they are vertical angles that are supplementary. Now let's talk about angles 2 and 5. 2 and 5. What do you think they are to one another? Are they adjacent? They're not. They're non-adjacent. Do we know anything about their measures? Do we know that when we add them together they equal 90 or 180? We don't know anything about their measures. The only thing we know about angles 2 and angle 5 is that they are created by two intersecting lines, and therefore they are a pair of vertical angles. Vertical angles make a V, two V's when they are created. Let's talk about this last pair, angles 5 and 6. 5 and 6. Well, what we know about 5 and 6. They share a common vertex and a common side, which makes them adjacent angles. They're too large together to be 90 degrees, too small together to be 180 degrees. They are not vertical angles. So all we know about angles 5 and 6 is that they are next door neighbors. They share a common vertex and a common side, so therefore they are adjacent angles. Now we've explored these several different pairs of angles. Let's move on. A few moments ago I mentioned a linear pair. A linear pair is two adjacent angles whose opposite rays form a straight line. Their sum is 180 degrees. So this is a pair of adjacent angles because they share a common vertex and a common side. Their opposite rays form a straight line. They are a linear pair. They are a pair that create a line. The linear pair postulate says if two angles form a linear pair, then they are supplementary, meaning together they equal 180 degrees. Example 2, finding missing angle measures. Let's use the linear pair postulate to find the missing angle measures here. If you know that angle KPL and angle JPL are a linear pair, then using the linear pair postulate, we know that the measure of angle KPL plus the measure of angle JPL is equal to 180 degrees because they are supplementary. If angle KPL is represented by the expression 2x plus 24, and angle JPL is represented by the expression 4x plus 36, we can substitute in those values to solve for these missing angles. We would combine like terms, 2x and 4x to get 6x, and 24 and 36 to get 60. Now we'll use the subtraction property to isolate the variable, and the division property to know that x is equal to 20. Now that we have solved for the value of x using our definition of linear pair and the linear pair postulate, we can substitute in the value to find these missing angles. If we know that x is 20 and KPL is represented by 2x plus 24, then we know that 2 times 20 plus 24 would be the measure of angle KPL. So it would be 64 degrees. Knowing that the value of x is 20, the measure of angle JPL is represented by the expression 4x plus 36. So we can substitute in the value of x to solve for the angle JPL. We're going to have 80 plus 36, which is 116 degrees. When we add these two together, we know that they are a linear pair, and therefore they equal 180 degrees. If we didn't get the sum, we would know we made a mistake. Now let's talk about an angle bisector. Bisect is to cut something into two equal pieces. An angle bisector is a ray that divides an angle into two congruent angles. Its endpoint is at the angle vertex. So in this situation, ray BD is the angle bisector of angle ABC. And therefore, ray BD divides angle ABC into two congruent angles. So angle ABD is congruent to angle CBD, because ray BD is the angle bisector. In our third and final example for tonight, we're going to use the angle bisectors to find angle measures. In this diagram, you are given that ray XY bisects this angle WXZ. So because it bisects the angle, we know that it cuts it into two congruent angles. So angle WXY is congruent to angle ZXY. Because angle WXY is congruent to angle ZXY, the measure of angle WXY is equal to the measure of angle ZXY. So we can substitute in these values given for these angles in order to solve for the value of x and therefore find the measure of WXY. So if angle WXY is represented by the expression 7x minus 7, and angle ZXY is represented by the expression 5x plus 3, we can collect all our variables on one side and all of our numbers on the other, using the subtraction property and the addition property. So we'll get that 2x is equal to 10, because I subtracted 5x from both sides for 2x, and I added 7 to both sides for 10. And therefore, x will equal 5 using the division property. We can find the measure of this angle, WXY, because WXY is represented by the expression 7x minus 7. So the measure of angle WXY would equal 7 times 5 minus 7. So it's 28 degrees. Because we know that ray XY is an angle bisector, we know then that the measure of angle YXZ, or ZXY, should also equal 28 degrees. So let's substitute in the value that we found for x to make sure. If it's 5x plus 3, then the measure of angle YXZ would be 5 times 5 plus 3, which is also 28 degrees. Using the angle addition postulate, adding these two angles together, we could say that we know that the measure of angle WXY plus the measure of angle ZXY or YXZ, however you want to name it, is equal to the measure of the larger angle WXZ. So therefore, when we add these two together, 28 plus 28, we know that the measure of WXZ is equal to 56 degrees when we add the two angles together. That's the end of our notes for tonight. As we're wrapping up, please think about this. How does the term linear pair describe how the angle pair looks? For tomorrow's class, we'll talk about it. So think about that tonight. How does the term linear pair describe how the angle pair looks? Have a good night. See you tomorrow.